Special right triangles. Special right triangles come down to two very particular triangles that we can generalize from. Using Pythagorean theorem, we can say that 1 squared plus 1 squared equals x squared. So 1 plus 1 equals x squared, and 2 equals x squared. Now when we square root both sides, we get 2 is the square root of x. Sorry, x is the square root of 2. For this triangle, we can say that 1 squared plus y squared equals 2 squared. It's tempting to say that that y means is 1 then, but we have to actually square the pieces first. Subtracting 1 gives us y squared equals 3, and square rooting gives us y equals the square root of 3. So that tells us what these side lengths are. Well, these come up often because this is half a square and this is half of an equilateral triangle. So because of that, we know what these angles are. These are 90-degree angles, and these are half of 90-degree angles, so those are both 45. In an equilateral triangle, we know that the angles are 60, so then that angle will be 30. So the pattern is that these are 45, 45, 90 triangles, and these are 30, 60, 90 triangles. Those make up our special right triangles. The idea is, when we have a special right triangle, if it's a 45, 45, 90 triangle, it always follows this pattern of x, and x squared to 2. If it's a 30, 60, 90 triangle, it always follows this pattern of y, 2y, and y squared to 3. So you want to know the names of the different sides so that it is easier to remember, easier to talk about. The hypotenuse is always across from the right angle. And the other two sides are called the legs. Those are the sides next to the right angle. Once we have that in our 30, 60, 90 triangle, the hypotenuse is still the side across from the right angle. But you notice that y and y squared to 3 are not the same. So the legs are the same in a 45, 45, 90, but not here. So I want to describe how they're different. One of them I will call the short side, and one I will call the long side. So the long side is going to be always across from the 60-degree angle, and the short side is always going to be across from the 30-degree angle. That's because the longer side is across from the larger angle. The hypotenuse, of course, is the largest side, and it's across from the largest angle, the 90-degree angle. So if you're ever looking to see, wait, what side am I talking about? Look at what angle it's across from. The long side is always across from 60, the short side is always across from 30, and the hypotenuse is always across from the right angle. Another way to abbreviate these rules is to use these equations, that in one type of triangle, the hypotenuse is always square root of 2 times the leg. In the other triangle, the hypotenuse is always the short side times 2, and the long side is always the short side times square root of 3. So when I see a problem like this, first I identify that it's a 45, 45, 90 triangle. These only work if we have a right angle and 45 degrees. Next, I want to identify which side is which. Well, this is the hypotenuse because it's across from the right angle. Now, these are the legs. So this 6 tells me that the other leg should also be 6. So y equals 6. Then the other rule says the hypotenuse is the leg times square root of 2. So the hypotenuse is the leg times square root of 2. The hypotenuse is x. The leg was 6, and then square root of 2. So that's what I write for x. That's what I write for y. Another example. This one is different because it's 30, this is 60, and that's 90. So I can look at the angles to identify which side is which. There's the hypotenuse. This is the short side because it's across from 30, and y is the long side because it's across from 60. Now, the hypotenuse is the short side times 2, So the hypotenuse is x, and that's the short side, 3 square roots of 3 times 2. And when you do multiplication like this, you multiply what's outside the square roots, and you can multiply what's inside the square roots. So 3 times 2 gives us 6 square roots of 3. And that's what we leave for x. For the long side is the short side times, oh, what is it, multiplied by the square root of 3. So I can take this 3 square roots of 3 and multiply it by the square root of 3. So y equals 3 square roots of 3 times 3. 3 times the square root of 9. And if you know square root of 9, square root of 9 is 3, which gives us 3 times 3 is 9. So the side lengths are 6 square roots of 3, and this is 9. Here, this is a 45, 90 triangle. We want to identify which side is the hypotenuse. So the side labeled 6 is the hypotenuse because it's across from the right angle. These are the legs. So the rule says that the hypotenuse is the leg times square root of 2. So how do we get rid of the square root of 2? Well, we divide by square root of 2. So 6 over square root of 2 is the leg, which is x. Now, even better is if you are going to rationalize this denominator. We rationalize it by multiplying by square root of 2 over square root of 2. And that gives us 6 square roots of 2 over 2, or 3 square roots of 2. So the best answer is that this is 3 square roots of 2, and this is 3 square roots of 2. Ooh, 3 square roots of 2. Yes. Last one. If we have this, well, this is the hypotenuse. 60 is across from the long side, and y is across from the short side. From the hypotenuse, one of the rules for a 30, 60, 90 is the hypotenuse is 2 times the short side. So I'm going to say 6 square roots of 2 is 2 times y. Now if I divide by 2 on both sides, I get 3 square roots of 2 is y. The other rule for a 30, 60, 90 is that the long side is the short side times square root of 3. So from this rule, we can say the long side was x, the short side was 3 square roots of 2, and then we're multiplying by square root of 3. Square root of 2 times square root of 3 is the square root of 6. So the long side will be 3 square roots of 6. And that's how we can calculate with special right triangles. Thanks.